Okay, now next question number 11, part 1. Simplify cos 90 plus theta into sec 270 plus theta into sin 180 minus theta from cosec minus theta cos 270 minus theta into sin 180 plus theta. So what you need to do is, first you need to check which angles are negative. So here we are getting cosec minus theta, so we can write it as minus cosec theta, but in the other angles we need to check which angles are greater than 90 degree, and we need to convert it in the form of 90 into n plus theta. So this can be written as cos 90 into 1 plus theta. Then next one is sec 270 plus theta, which can be written as 90 into 3 plus theta. Then we have sin 180 minus theta, it is 90 into 2 minus theta. Then cosec minus theta is minus cosec theta. Next, cos 90 into 3 minus theta because it's 270. Then we have sin 90 into 2 plus theta. Now you check which values are odd and which one is even. So here this number is odd. We need to change this trigonometric ratio. So we get here sin theta. And this angle is coming in the second quadrant because it is 90 into 1 plus theta. Okay? Now in the second quadrant, sin and cosec are positive, not cos. Change the sign. Next, sec 90 into 3. Again we are getting odd number. To change this trigonometric ratio, sec changes into cosec, so we get cosec theta. But this angle is coming in the fourth quadrant. Okay, and you know in the fourth quadrant, cos or sec are positive. So we'll be getting plus sign. Next, sin 90 into 2 minus theta. So here we are getting even number, therefore there is no change in trigonometric ratio. So it remains the same. Therefore we get sin theta, and this angle is coming in the second quadrant. And second quadrant, sin is positive. Now out here we will be getting minus cosec theta into, next, cos 90 into 3. 3 is odd. So we need to change this trigonometric ratio. Cos changes into sin. So we get sin theta, and this angle is coming in the second quadrant. Why? Because it is 90 into 3 minus theta. Okay, 390 degrees minus theta. So it is coming in the third quadrant. Third quadrant, which angles are, which trigonometric ratios are positive? Tan or cot. So therefore we need to change the sign. Now we have sin 90 into 2 plus theta. So this number is even, therefore there is no change in trigonometric ratio. Therefore we get sin theta, and this angle is coming in the third quadrant. In the third quadrant, tan and cot are positive, not sin. Change the sign. So here we are getting minus sign. Out here also we are getting minus sign. Minus into minus into minus. And other terms are getting cancelled. Okay, so the answer is 1. There are some more questions to be done from the same exercise. From page number 106, question number 13, part 1. Question is, if ABC be the angles of a triangle, then prove that sin B plus C plus sin C plus A plus sin A plus B upon sin pi plus A plus sin 3 pi plus B plus sin 5 pi plus C is equal to minus 1. So since it is given that ABC is the angles of a triangle, and you know in a triangle sum of the angles is 180 degree. So from this triangle we can write A plus B plus C is equal to pi, that is 180 degree. Now why are you writing this? if you look at the numerator, there are 3 terms given, and in each term there is a binomial. That is b plus c. Out here we are getting c plus a, and then a plus b. So these angles can be reduced with the help of this formula. So easily we can get b plus c from here. If you want to find b plus c, we get pi minus a. Similarly, for c plus a, we will be getting pi minus b, and a plus b is pi minus c. So, in case of b plus c, we can easily write pi minus a. Okay? Because we need to prove that this is equal to minus 1. So now, for b plus c, we write pi minus a. Similarly, for the other 2 terms, we can write pi minus b and sine pi minus c. And this remains the same. You can write it as it is, pi plus a plus sine 3 pi plus b plus sine 5 pi plus c. Now, for sine pi minus a, you know pi is 180 degree. So, for this angle, what you can write is, if it is written as pi minus a with sine, we can write it as sine 90 into 2 minus a, because pi is 180 degree. Now, if a is even, then there is no change in trigonometric ratio. At the same time, you need to check this angle lies in which quadrant. So, this angle lies in the second quadrant, and second quadrant is positive for sine and cosec. So, from here, what we will be getting is, anyway, you can write it as 90 into 2 minus a. Similarly, for pi minus b, it can be written as 90 into 2 minus b, and sine 90 into 2 minus c for pi minus c. Next we have sine pi plus a, 90 into 2 plus a plus sine, this is 3 pi plus b. You know pi is 180 degree, that is 90 into 2. So out here we will be getting 90 into 6 plus b plus, then we have 5 pi, so it is sine 90 into 10 plus c. Okay, next to find sine 90 into 2 minus a, as I told you, this number is even and this angle lies in the second quadrant. So the answer of this is sine a. Similarly, for sine 90 into 2 minus b, we will be getting sine b, because this number is even and it lies in the second quadrant. Similarly, for the third part, from here we will be getting sine c. Now, the denominator, if you look at this, it is sine 90 into 2 plus a. So, a is even, but this angle lies in the third quadrant. Why? Because it is given as 90 into 2 plus a. So, 290 degrees, then some angle is given. But you know, in this quadrant, tan and cot are positive, not sine. So, the answer of this is minus sine a. Similarly, if you look at this 90 into 6 plus b, this angle is coming in the third quadrant, right? And this number is even, so from here you will be getting minus sine b. Next, sine 19 to 10 plus c. Again we are getting even number, so there is no change in trigonometric ratio, and this angle is also coming in the third quadrant, right? Because you know one complete rotation is 360 degree. Okay? So since it is coming in the third quadrant and because of the even number, we will be getting minus sine c. Now simplifying this, we get minus sine a plus sine b plus sine c. So that is minus 1.